Hello, today we're going to look at CPCTC, also known as corresponding parts of congruent triangles are congruent. Now there's a lot more details we can go into, but we're going to not be looking at the proof base. This is really just an introduction to when congruent parts happen on congruent figures. So let's start off talking about what congruent figures are, of course. Congruent figures are two figures are congruent if every angle and every side of one figure is congruent to every angle and every side of another. So in this situation, we have two triangles. That means I'm going to have three angles and three sides congruent to each other. So let's look at the angles here. You can clearly see in the picture that angle B is marked as congruent to angle E. Further, angle C, it's got the double marks, it's congruent to angle F. And angle A with the triple marks is congruent to angle D. So I have all three angles of one triangle congruent to all three angles of another. On the other side of that, I need to look at the sides. So you can clearly see here that BC has a single mark here. BC is congruent to EF. AB with double marks is congruent to ED over here with double marks. And AC is congruent to DF. Which leads me to conclude that triangle BCA is congruent to EFD. Now, notice that I tried to do the colors to line up. It's very important that you recognize that BCA here and EFD line up in corresponding parts. Now, how can we use corresponding parts of congruent triangles? First, I do want to mention that there are several shortcuts with triangles that are out there. They all have their own abbreviations and they all have their own special rules. This is not the focus for today. Today's focus is not to talk about that. It's only to talk about corresponding parts. So here's an example. Given that triangle HOT is congruent to triangle DOG, can you name all the corresponding angles and sides? Well, let's start with the angles. You can see that H and the D correspond to each other in the naming of the triangles. Therefore, the H is congruent to the D. Similarly, O is congruent to O, and angle T is congruent to angle G. Written properly, those should all correspond to each other. Now that we know that, we can look at the sides, and we can say that HO, the first two here, have to be congruent to DO, the first two there. Similarly, OT, second and third, has to be congruent to OG, the second and third. And finally, HT would be congruent to DG. Another example using more algebra has these two triangles congruent. Go ahead and take a moment on your own to see if you can find X. Alright, knowing that triangle LMN is congruent to triangle SRT, we also know that therefore that L is congruent to S and N is congruent to R, marked by the single marks here and the double marks here. Therefore, we know that S has to be a 65 and R has to be a 55. So I'll mark those in my picture. Now we'll just use the old triangle angle sum theorem, and we know that all three angles in triangle SRT must equal 180 degrees. Substituting in, I can solve for T and find it's 60 degrees. Another example. Take a few moments to look at this and see if you can determine X. Excellent. So the first thing I'm going to do in a situation like this is label my diagram. So I know that WX is 3. I know that XZ is 2X. And I know that YV here, all of that must be equal to 21. Well, since it was given to me that triangle WVZ was congruent to triangle YZV, I know that WZ has to be congruent to YV. Now, furthermore, I recognize that WZ here is made up of two parts, the red part and the green part. And I know that WZ would be adding those two parts together. Putting all that together, I know that WX plus XZ has to equal VY. Substituting in and solving for x, I find that x is equal to 9.